welcome back, Mr. Bergman. Today we're going to take some of the stuff that you guys felt uncomfortable with last video where we didn't have numbers kind of matching up, and we're going to talk about balancing equations. And to help you understand this, I'm going to start off with when I first became a bachelor. And my grandma, as many of your grandmas probably are, was an amazing cook. And so she gave me recipes to work on my own. And when I looked at her recipes, they had put chicken in and put salt in and whatever else. And I would call her up and I'd be like, well, how much? And she, in typical grandma fashion, would be like, just put enough in. Well, just put enough in is not very helpful to us. And similarly with equations, we want to make sure that we know amounts of things. If I were to tell you, Mr. Bergman, we need to put together a chocolate chip cookie like we used in the previous example, and I said we need flour, eggs, sugar, chocolate chips, vanilla, and I didn't tell you any quantities, and you just randomly put amounts in, wouldn't that be a pretty horrific cookie?
10 eggs, a cup of sugar. I mean, how much, right? What's the right amount? I think the recipe I used 2 eggs and then 2 cups of sugar and 4 cups of flour, whatever, right? Or, you don't put a gallon of vanilla in, right? You just put a couple of tablespoons, right?
But I'm glad you brought up vanilla, because if you've ever tasted vanilla smells like heaven, but it attacks as if it's evil.
Yeah, don't drink it direct. So in a balancing equation, we have to indicate the amounts of the things. And remember, we talked about how things are going to bother you. So Mr. Dimitrievich, what are the rules when we're balancing equations? So what's rule number 1?
Well, you see them here in front of us here on the board here in the middle. And the biggest rule of all is this: we can never mess with subscripts when we're trying to balance things off. So we're going to use coefficients to tell how many of each thing. So if I put a 3 in front of my eggs, that's going to tell you I need 3 eggs, right? So in these cases right here, when we do an example, whenever we need to change to balance things off, we're going to put coefficients in front of those elements.
Now, as a back note, you haven't really explained what a coefficient is. What's a coefficient? So when we have a coefficient, so if I've got, oxygen gas, the number in front is the coefficient. So if I have 3 oxygen gases, this is the coefficient right here, this number in the front. This is the number I'm allowed to change. I can't change the 2, that's the subscript. Or if I've got, PbOH4, some kind of, lead 4 hydroxide, I'm allowed to change only the number in the front. And that could be a 1, a 2, a 3, it could be a 24. This is the number that you can change when you're balancing the equation. That's the coefficient. So rule number 1 is no touchy, the subscripts, only the coefficients. What are the other rules?
Well, if you take a look here, we typically want to start with things that only appear once on each side, because that allows us to balance them off pretty easily. Good. The other thing that's kind of tricky and is really, really helpful is instead of breaking apart each polyatomic ion into individual atoms, we can treat them as whole units. So why don't we try an example here?
So here we have iron oxide, which is one from the last video, if you recall, and it breaks down into iron and oxygen, but it's Fe2O3 breaks into Fe plus O2. Now what I like to do, guys, is I like to put like a line under each of them. That's the coefficients. And now the only thing I'm allowed to change is, if you will, the red numbers. So Mr. Dimitrievich, what am I going to do first here?
So you can pick any element that you want to start with. I typically start with the more complex one. So we're going to start with Fe2O3. And how many Fe's do we have there?
2.
We have 2. So we're going to put a 2 where?
Right here. So now we have 2 Fe's and 2. Notice I didn't put a 2 down here. I can't do that, right? Okay, the only thing I do is the 2 in the front. Now what do I do?
Well, you have 3 O's there, and here's where it gets a little bit tricky, because if you have 3 O's and you have 2 O's over there, you cannot just like subtly change the 2 outside of the O into a 3.
And I can just do this.
Yeah, no, not so much, although that is fun.
That's changing the coefficient. I'm allowed to, I can't change, or that's changing the subscript. I'm not allowed to do that. I have to leave this as a 2. So how do I do this?
So it kind of comes back to our common denominator idea. If I have 3 O's on one side and I have 2 O's on the other side, I can take 2 of the O3s and 3 of the O2s and balance them off.
So if I put a 2 here, that means there's 2 times 3 or 6 O's. To fix the O's on this side, I get 3 times 2 is 6 O's. But Mr. Dimitrievich, that just screwed up my iron. I solved the iron problem. Yeah. Now it's all broken.
And this is one of the things. This is one of the things I want to encourage you guys as you do these. View these as kind of fun puzzles, because when you change something and you put different coefficients in, it may change something that you already balanced. You may have to go back and forth a little bit. So as Mr. Bergman is doing right here, there was a 2 there before because we thought we only had 2 Fe's. But now if you take a look, if you see we have 2 times 2, That's 4 FEs on the left-hand side, so we have to go back and rechange the 4 FEs.
So yeah, it's a puzzle, back and forth, like Sudoku or whatever, right? So you got to kind of do that one. All right, let's do some more.
By the way, just to be clear, we always encourage you guys to double check to make sure you have the correct number of each one at the very end.
Yeah, so as a point, maybe we haven't said this, guys, is that the key is to have the same number of irons on both sides, the same number of oxygens, or whatever the elements are, because you can't like create or destroy matter. It's like the conservation of mass of the universe. You can't break, all you can do is make the same elements on the other side, but they're going to be rearranged and bonded to somebody else. So here's a reaction, Mr. Dmitrich, where I have sodium carbonate plus aluminum makes aluminum carbonate plus sodium. Now notice I've written this out correctly. It's important that you do this with the charges and all that stuff. So I need to, how do I balance this? What am I going to do? What do you think I should start with?
Yeah, typically what we like to do is start with the most complex compound on there, because that sometimes other things will just fall into place. So I'd start with aluminum carbonate on that side.
Yeah, it's got a 2 and a 3, where this has just got a 2 and a 1. Notice that this carbonate is in parentheses. It's not there, but we can kind of think in parentheses, because one of the rules, if you recall, is if you have a polyatomic ion, and the one that you have is carbonate, CO3, think of it as one entity, not one C and 3 O's, but as one CO3, or in this case, 3 CO3. So how do I fix that? So if this is the most complex one, and I can either fix my aluminum or I can fix my carbonate. So let's fix the aluminum first, since it's first. So if I've got 2 aluminums here, what do I do?
Well, you need 2 aluminums on the side.
Back to this side, and I put a 2 here. By the way, by me doing this, I'm making an assumption that there's a 1 in front of this aluminum carbonate. We don't have to put a 1 if it's not there. It's like, these are coefficients. Think of math class. You can say 1x, or you can just say x, right? For math class, it's the same thing. Now I've got some carbonate issues. How many carbonates are there here?
Well, you have 3 carbonates on this side, and then on the other side, as you just showed, you have 1 unit of carbonate. So if you only have 1 on that side, you need to have 3 of them. So you're going to put a coefficient in front of it.
Important. I'm not changing another coefficient. I'm not saying parentheses 3, because that changes what it is. I'm just adding numbers to the front. But that gives me how many sodiums?
Well, now that gives you 6 sodiums. And
So
you have only 1 over there.
I just put a 6 there. And let's double check. How many sodiums here? 3
6.
times 2 is 6 on this side. 6 times 1 is 6. How many carbonates? Now remember, this 3 multiplies this whole thing by 3. So there are 3 CO3s. We jump over here. How many CO3s do we have? 3. We have 2 ALs here. We have 2 ALs here. Star, we got it. So here's a reaction, Mr. Dmitrich. This is a certain type of reaction, and there's a trick when we're trying to solve these types of problems. These are, we're going to learn later, called combustion reactions. They are the funnest ones. They blow things up. You get to set us on fire in class. It's super awesome with reactions similar to this. But again, we can only change the coefficient. So when you have a combustion reaction, again, we'll learn more about that in a video or two, is that there is what I like to call the Cho-2 rule. These are the hardest ones to balance, but if you do the Cho-2 rule, you can solve that. What that means is you balance the carbon first. If you have like C's and H's plus oxygen, they most of the time make CO2 and H2O. And that means you balance the carbon first, and then the hydrogen, and then the oxygen, and if it doesn't work out, you double it. Cho-2. Make sense? So let's do the carbons first. How many carbons on the left side of C4H10?
4.
4, so I'm going to fix that by putting a 4 next to the CO2. Now it's Cho-2, so what do I do next? Hydrogens. How many hydrogens on this side?
You got 10.
10. So to fix that, by the way, I put the 4 here into the C because there's only C's in the carbon dioxide. In the hydrogen, the only place to find hydrogen is in the water. So to make that 10, I put a 5 here. Now I have to do my oxygen. Now, there's 2 oxygens on this side, and there's quite a few on this side. We have to kind of like do some math here. 4 CO2s means 4 times 2. So there are 8 oxygens in CO2. And how many in the water? In the 5 waters, Mr. Dmitrich?
You got 5.
5. So 8 and 5 is 13. So I've got 13 here. I have to put a number here. Uh-oh, what's the problem?
Well, you
I can't put 13 there. Yeah, that's half of an oxygen. So what do you, Cho-2, so what do? We double everything. So I'm going to double the C4H10 to 2. I'm going to double the CO2 to 8. I'm going to double the 5 waters to 10. Now, How many C's? 8. C, 2 times 4 is 8. How many C's? 8 times 1. How many H's? 2 times 10 is 20. How many H's? 10 times 2 is 20. And now let's add up our O's on this side. How many O's here? 8 times 2 is 16 from the CO2. And then 10 times 1 is 10 from the water. 16 plus 10 is 26. What number goes in front of the O2 here?
Now you gotta put a 13.
It's 13, because 13 times 2 is 26. So it's 2, 13, 8, and 10. Those are the coefficients. So folks, that's how you balance equations. There are lots of other sort of idiosyncrasies. You're going to get good at this by practicing. And we're going to give you plenty of time to practice. And one last thing. We're drawing them and we're writing out the correct formulas. But there are going to be times where we give you the words, and then you have to write the words, and then you write the formulas, and then you balance it. And the mistake everybody seems to make is they'll write FeO or something like that instead of Fe2O3, or they'll write out the wrong formula, or like they'll not write O2, but they'll write O. So it's super important that you write out the formulas correctly. Hey guys, that's all for this video. We'll see you in class.
Indeed. See you next time.